People have the need or the desire, I mean, just use that system. They are there for people to play with or to use or to do demos. There's also free Wi-Fi all over, people already noticed. So you can get your Wi-Fi connected. I didn't try it yet, it's open, right? You just say click and it works. Is it a little bit fast? Yeah? Excellent. So as I said, we have tomorrow Elephant's Dream 3D premiere. We might even have a molecular 3D premiere. You think you might? You met Wolfgang already?
I didn't meet him, but I'm going to look for him as.
Where's Wolfgang? Wolfgang is in the back. It's, put up your hand, Wolfgang. Okay. If you can meet, maybe talk. We have a little screening of the other 3D content. Would be cool. Because the theater is reserved mostly for watching film. There will be a couple of short sessions. If people do want to have a spontaneous meeting with people, tell me or Nathan. We might find a place in our schedule to add that still. But you can also do that on Saturday, where between 6 and 8:30, when we start the award, there's an open stage. Everybody can go here, take a laptop, and do something interesting. Show something. We will make a nice schedule for that. Everybody who feels like, okay, I want to show something cool, or I want to demo something, or I have a nice animation made, or I want to complain about the Blender compositor, for example, come up and show it, and then you can see what you are doing. Talk to Nathan, he's making a schedule for that. And that's it. So thank you for listening. I hope you all have a great Blender conference. Exactly in time for Dalai. Where's Dalai? I haven't seen it.
can start? First of all, sorry about the delay. We took the wrong bus, we couldn't find a cab, and we said Bali instead of the Bali, and kind of it's confusing here. So my name is Dalai Felinto. I'm from Rio, Brazil. Mike Penn, he's from Vancouver. We actually work together in Vancouver, and together with us in this work, but that couldn't be present, is Martin Upitis. Martin is actually now in Portugal, so he's having fun. So this project, is a mix of what you call the cosmic particles sensors. We're talking about one of the huge, if not the largest, portable domes in the world, and the Blender game engine, all then coupled together. This is the final result. The goal of this talk is to show how we got there, a little bit of the process, and of course some technical details for the curious minds. So first things first, I think I got back to the same slide. No. Oh. Sorry. Technical problems. Yeah. So let's first talk about science. First, an introduction. Blender game engine, as a lot of people know, is not only used for games, and actually one of the main niche in markets where it can be applied is actually for scientific visualization. And once again, it was actually the perfect tool to fit the interest for this research. So in the Roosendaal University, the Professor Saibran, the young, they had a research on muons. Muons are basically subparticles of the protons. So every day, every time, you have thousands and thousands of protons, particles hitting the atmosphere. Once they hit the atmosphere, they explode in a ring of subparticles. The subatomic particles with the highest energy level, they tend to keep the same direction as the original particle hitting the atmosphere. If they keep the same direction, if you're able to detect them, you're actually able to trace back where those particles came from. And they find out that they came from the black holes in the space, in outer galaxies. So pretty much they figured out a way to create a detector of black holes. And that was very exciting, but in a sense that was also very inaccessible for the general audience. We're talking about invisible subparticles, and they're not only small, but they're actually out of a range of visible light. And therefore, they come together with Barney Brummer, is a producer, to find a way how they could reach a more general audience, more like people like you and me. And they put together a project that won the Academic Year Prize. It's a Dutch project, Dutch award. And the key word in this project is experimentation. They're experimenting how science can be brought to the audience. They're experimenting technology. They're experimenting creations. This is a look of the real sensor they have. This, if I'm not mistaken, is in Argentina. This is a look at another sample of the real particle sensor. In that case, it's a ionized helium field. So whenever we have the particle hitting this container, you actually can visualize it for real. And our goal is to bring this more technology actually. Well, we'll talk about again for the general audience. And we're not talking about new mediums. It's not only about exploring technology that people are using, but DOMs, and I'm going to explain what is DOMs, and even real-time application. They're, in a sense, they're quite a new field of the technology. And we as an artist and developers and geeks in general, we're quite acquainted with that. But there's still a lot of people out there that they don't even realize how this kind of technology can be used for their mainly lives. So we're talking about communication. We have a science, we have a university trying to communicate with people. The artists, they want to communicate something through their art, so we want to communicate one single message. It's kind of strange because they're talking about a very serious research. They got a publication on the Science magazine. They have been for, I believe, around 2 to 3 years already publishing their final results. And on the other hand, what they wanted to produce is something almost positive. So we're talking about 3 days of silent disco, music, light, and visuals. Silent disco is something that's now a trend in Europe, in part of Europe. That's basically a nightclub or a night event where you don't have ambient music, but you actually have headsets. So you can have 1,000 of headsets. And if you take it off, you can have given interviews, you can have general normal conversations, you can just enjoy a little bit of silence. You have DJs and you have generated music. So we're talking about how the science, their research was actually bringing this breakthrough discovery for people. But if moons are invisible, how can people interact with them? How can people experiment the universe? That's one of the catch lines we're using. And one of the ways is through music. If you can have music that's played according to the input coming from these particles, we are in a sense allowing people to interact with something they would not interact otherwise. If they just go there and have fun, and they're having fun because part of the music is being played by the galaxy, this is part of the goal of the project. When you're talking about generated music, it's basically here in the left, you see these columns. It had 6 columns in that space, and each column had the same song played, but the volume in each column was based on how many particles were hitting that region on the space. And of course, we had DJ, regular music. Yeah. And generated effect light. Well, only have music wasn't enough. That's what actually Barney brought into the project later, right before. So they actually wanted people to experiment that visually. And especially if you're talking about something that's invisible, that was quite of a challenge. So one thing was what I call lights. So we had this music, like DJ light table, where you could lighten up according to the direction of the particles. And you also have these sticks, that's glowing light sticks, that you would light up whenever you have a new hit, and we have like 6 hits, they would change colors and go all fancy. And that's all was nice, but what was nicer actually was they actually wanted to use interactive real-time visualization. And here we are talking about not only about Blender Game Engine. Here on the left, we have the work of the VJ and artist Mamet Ashken. He's a British, and he works with 2D technology. But then our goal was actually to bring 3D technology, real-time technology, into the game. To see how we could integrate video game technology with art, with entertainment, and with science. So we talked about the content, but one of the key elements of this project is this 30-meter little toy here. They call it portable, although we actually need a few trucks to move it around. But actually, this was the second time this dome was put together into one piece. And the first time actually using, well, second time used for interactive content, but first time with real-time 3D content. So we're talking about a 30 meters diameter dome, where it can fit up to 1,000 people. And what else? Oh, well, since we're in this picture, you can see here in the top on the left the real sensors. So we had 2 samples of the sensors at the beginning. These are the new sensors they built for this installation. So we have 12 sensors in the top and 12 sensors in the bottom. So why immersive domes? Well, the second actually is the most succinct because they're cool. They are really cool. But when you're talking about immersion, a lot of people keep talking about 3D technology, 3D glasses, 3D cinema, and video game. But although that's trendy and it's still something new to be explored, that actually has a huge lack that technologies such as Dome, they have like a great advantage on that. That's the big field of view. So in our case, that Dome seeing 3D doesn't matter much, but matters for it to be immersed in that projection, in that creation. It's like if you're actually really glazing to night sky. And the other thing is, well, unexplored medium. Again, domes are actually pretty old technology. A lot of people know domes in planetariums. There is, for example, the Omnimax is the La Geode they have in Paris. So they'll be using domes for entertainment, education, for military sometimes. But to use domes with real-time technology, real-time like games itself, it's still something quite new. There are a few engines that support this kind of medium, and even though a lot of people are simply using for, well, when you're talking about videos, it's for documentaries on moon landing or to stars, to constellations, all around astronomy. But we think that the dome can be something else, can be something more. It's a medium that, as an artist, we can paint whatever you want. And one of the big motivations for this project was try to put these technologies together. Mike?
I can take over from here. So one of the reasons why we approached this project using the Blender game engine is, well, a few reasons. One is really this is the only thing we know, but I can come up with a few other reasons why Blender is really the perfect software for this project. First of all, it's one of the few softwares that integrates the game engine with sort of the entire 3D modeling and texturing pipeline. So you don't have to export to anything else. You basically model the thing and hit run. I'm not going to go into details. But so that gives us a lot of freedom where you can rapidly prototype something and see your result really quick. Because one of the problems one of the problem with this type of project is you sometimes don't have a clear idea of what you want to do, what you want to accomplish in the end. So having an engine that lets us, experiment really quick is a really great tool. Also because it's open source and we needed an engine that supports the dome rendering mode in which Dalai worked on. So being open source and being able to output the game engine to a dome format really helps us. So. That's it. Also, when we ran into problems, which we did, being open source means we can fix it really quick. So it's also a plus. These are some of the domes. This is one dome that, in Australia that Dalai worked on. So actually, you can probably take.
Yeah, this is the dome in the Wasp University of Australia, Western Australia. This is Professor Paul Burke. He's a researcher there that helped the implementation of the dome mode into the Blender game engine, basically to show one of the reasons to use the game engine and why the client, the producer, contacted me back then and wanted to try with this open source technology, was because he knew back then that we were already one of the most reliable tools for that. Kind of neat, being open source and at the same time cutting edge. Just like how. So how to do that? Do you want to say that? How to integrate. We basically have these sensors, real mechanical hardware built specifically for this installation. We had a second layer where you need to have a computer that could actually read the sensor was sending MIDI output format. You would have to read that, decode that, and sending over to a computer that could actually interpret this data and produce visualization. The visualization actually wanted to produce in Blender was still an open end at that time. But let's assume we're talking about visualizing the particles. So whenever you know that the particle is hitting the dome, you actually want to visualize its path into the canvas. So we basically need to get this information pretty much decoded in Blender. That we're using OSC for that, is an open sound protocol. And from Blender, that's not enough. You still need to send to another computer that's responsible to split to the projectors. We're talking about, again, a 30-meter diameter dome. You can't fill this dome with one projector, 2, 3. We actually had 6 projectors, and yet we are not filling the whole canvas. So actually we're using only part of the dome. So we had a secondary computer, actually 2 computers, responsible to take the input from Blender, that was this whole projection, and actually split accordingly to the projector. And then you have the dome layer. In order to get to the end of the solution, we knew we had a big problem. We knew we have a lot of unknowns in the middle. So we gave ourselves around like 1 year deadline for the project. A little bit open end. The deadline changed a lot of times. When you talk about 1 year project, of course, you're not working full time every day into that. But a lot of problems need time. You need to sleep on a lot of the problems. That's quite common. So I would say it was a good time for this one. In our case, the original goal was to create an art contest. We didn't want to exhaust all the possibilities of visualizations for this phenomena. Again, we're talking about an invisible subatomic particle. There's no right or wrong way of visualize it. And if you're also using open technology, why not talk with the art community and produce something together? That was the original idea. So in that case, my role on the process was, well, basically to create a framework. So do this interface between the science group, the DOM group, and the Blender community, and actually provide something people could work on top of that and create contents. And another goal was actually, of course, I was looking at Blender 2.5. I happen to be a developer myself, and it's so exciting to see how Blender 2.5 was putting up together back then. So in the beginning, I was testing if it was not reliable, and I think I can go to the next one. Yeah, and at some point, since again we have 1 year, so kind of paraphrasing the quote from JK, it's not what the Blender can do for you, but what you can do for Blender. And it's quite true. If you have a budget, if you're talking about a research project, you have time. So why not actually take this as a chance to help improve and developing Blender? And 1 year ago was fun because Blender is known as an animation tool. People sometimes don't prioritize the game engine inside Blender. And that's true. It's sad, but true. No, I'm not looking. But that's how it is. And so 1 year ago, we have the Blender player. That's a part of the Blender that actually allows you to run your game outside Blender. Totally unfunctional. It wasn't linking, it wasn't building. Simply, no one even knew that was broken, because actually it was even broken, although it wasn't building. We had the interface of all Blender was shiny, was new, was customizable. We had the data block lookup. And the Blender game engine, I think I can even show. Didn't have anything like that. We still need to type the whole name of the text, and you need to guess or not if that was right. Everything was still very white and bad formatted. It was pretty much the same code we had for the Blender 2.49, slightly ported over, but without using any of the 2.5 capabilities. Of course, so part of the project, since I wanted artists to work with the Blender 2.5, because I wanted more people to experiment with that. I wanted to create more sample files with Blender 2.5. And I wanted to use this as a possibility to explore and find and report and fix bugs during this process. So I took as one of my assignments to actually help work on the UI. Had a lot of help from Matt Abb from Australia. It's pretty cool. So this is just so again, this is a general overview of what you go through during the process. And of course, tests. We changed the number of projectors. We changed the soft